Hello everyone, this is Namita Basnotra and here I am with another video on whole numbers, and in this video I'll be teaching you the properties of whole numbers. So let's begin. Closure property of addition of whole numbers. So clearly when we are talking of addition means we have to add. So let's take two whole numbers, like if I take 4 and I take another whole number 5 and I add these, what do I get? The sum is 9. Now, is 9 a whole number? Yes, so it is a whole number. Let's take another example. For example, if I take 15, I add 10 to this, what do I get? I get 25. Now, my question to you is 25 a whole number? Yes, it is also a whole number. So looking at these examples, it is clear that the sum of two whole numbers results in a whole number. So we can say that the collection of whole numbers is closed under addition. So this property is known as a closure property of addition of whole numbers. Closure property of subtraction. So now let's subtract any two whole numbers. So can you think of any? Yeah, so let's take a whole number 5 and let's subtract another whole number, let's say 3. So what do we get? We get 2. So is 2 a whole number? Yes, 2 is a whole number. So let's take another one. If I take 6 and now I subtract 9, what will I get? I will get minus 3. Now is minus 3 a whole number? No, it is not a whole number. So what do we see? There we see that when we subtract two whole numbers, we always, in every case, we do not get a whole number, right? So therefore, we can say that whole numbers are not closed under subtraction. Commutative property for addition. Now, what do we mean by that? It means that if we take any two whole numbers and add these, and then we change the order of these number and add again, will the sum be same or will it be different? So let's take an example. So if I take a whole number 4 and I add another whole number to it 5, what do I get? 9. Okay, that's easy. Now let's change the order of 4 and 5. So I take 5 plus and then now I add 4 to it. What will I get? I get 9 again. So that means clearly that the changing the order uh, doesn't affect the sum. So that means we can add whole numbers in any order. So I can also write 5 plus 4 is equal to 4 plus 5. Therefore, according to commutative property for addition, the sum of two whole numbers is the same no matter in which order they are added. So now can you use this to simplify your questions? Now let's check the same for the subtraction. So if I take two whole numbers, for example, if I take 7 and 5, and let me just subtract these two. So 7 minus 5 is how much? That is 2. And now let me change the order. So I will be writing 5 first and 7 after that. So if I write 5 minus 7, will I again get my 2? No, this time I'll get minus 2. So I can see 2 is not equal to minus 2, right? That means we can say that subtraction is not commutative. Okay. So the next property is very interesting. It is associative property for addition. So what we will do is we will be taking three whole numbers here. So let's say if I take 1 and I add this to 2 and I have to add this to 3. Okay. And I'll do it in two different ways. I'll try to find the sum in two different ways and see what happens. So I'm going to now group these. Okay. That means, as you know, that we can add two numbers at a time. So this is my first group and this is my second group. And now I'll see whether the sum remains same or it changes. So 1 plus 2 is how much? 3. And I do 3 plus 3, and which is equal to 6. Okay. So here I have 1. So I will leave 1. So I'll first add this. So 2 plus 3 is how much? 5. And we already have 1 here. So 1 plus 5 is 6. So that means this shows that the results are same even if we change the grouping of numbers. So while adding whole numbers, we can group them in any order. And this is interesting, no? And this way you can make your calculations easy. You can group them in the pairs of tens and just calculate and add and finish. May I show you an example? So now if you have numbers like for example, you have 7 and you have to add this to 5 and you have to add this to 3. So what will you do? You can add 7 plus 3 first. That makes it 10, and you know that now the sum will be 15. So this is how you can use the properties to make your calculations simple. So children, this is the associative property of addition. Now let's check the associative property for it, subtraction, and see what happens. So I have here taken two examples for you. So the first example is here the whole numbers are 5, 3 and 2, and we are going to subtract these two, see and what happens. And our groups are, let me just highlight the groups for you. In the first example, we will group 5 and 3, and in the second example we are grouping 3 and 2 together and we'll subtract. So this is how we are going to follow the steps. So in the first example, if you say 5 minus 3 minus 2, what do I get? So 5 minus 3 is 2 and minus 2 is already there. So the right now the answer is 0. And in the second group, when I'll do 3 minus 2, I get 1. And a 5 is already there. So when I do 5 minus 1, answer is 4. So we can clearly see that subtraction doesn't follow the associative property. And in except few cases, maybe there is an exception. You may get 1 or 2 cases, like I have taken an example here. So this is an exception. Okay. An exception doesn't govern the rule, right? So let's learn the next property, which is very interesting one. It says distributive property of multiplication over addition. And I tell you, once you know this property, you can make questions, you can solve them very, very easy. Take an example here. In the first example, if you see, we have 15 and we have to multiply this by 8 plus 2. And instead of multiplying it by 8 plus 2, what I do is I add 8 plus 2. So that gives us 10. So when I multiply 15 by 10, it makes it 150. Now the similar thing we will be doing is that instead of multiplying two numbers directly, we'll try to break one number out of the two, if it's possible, to make it simpler. So here you have the example 2 with us. Can you see the example 2 here? Okay, so in this example 2, what we will do now to make, we have to now multiply 290 by 105. So in this case, to make the multiplication easy, we break 105 into 100 plus 5, and then we will use the distributive property. So what do? I write 290, I multiplied by 100 plus 5. So instead of 105, I have written 100 plus 5. And now we will multiply 290 by both of these numbers inside. So the first group is 290 into 100. And then I have to add this because there's a plus sign here. And the second number is 290 into 5. And when you will solve this, you get 29,000 and 1,450. And when you add it, this is 30,450. I tell you, apply this. This saves time and you can manage solving questions easily by using this property. So similarly, we can also apply the distributive property of multiplication over subtraction. So here I have taken again two examples. In the first example, I'm showing you, like for example, if you multiply 20 and there is a number 12 minus 2. What do? We first solve 12 minus 2 and write there the answer as 10. And when you multiply 20 by 10, I get 200. So that means it is possible to break the number by subtracting also. So now the question is, you have to multiply 200 by 98. So what will I do? I will be making it easy. So and I can break 98 as 100 minus 2 and make a group there. And then I will solve my question like I've solved over here. So it will be 200, and instead of 98, I write 100 minus 2. When I solve it, it gives me 200 into 100. And then you have to subtract because there's a minus sign there. I bring it down, and then it gives me 200 into 2. And when I solve it, it becomes 20,000 minus 400. And the final answer is 19,600. So we will be doing many questions using this distributive property so that you learn it by heart and you can make your calculations easy. So next is additive identity. That means that what do I add to a whole number to get the same whole number? So that means I want to add something to 5 to get 5. so that the identity of 5 doesn't change. Okay, that is additive identity. So what will I add to 5? I'll add 0. So we can clearly say that 0 is called the identity for addition of whole numbers, or additive identity for whole numbers is 0. So here's a chart that all the properties that we have done in this video. So after you go through all the properties, you can always read these and try to think some examples and see that whether you have understood these or not. And if you think you have not understood any one of these, then please go back to the video and watch it again. This is Namita Basmatra, and I'll be coming up with more videos for you. Till then, bye-bye.